Let's look at that very front page. Let's see. Do I want to be here? Yes, right here. Okay. If you guys look at this very front page, I just want to make sure that we understand the nature of some of these problems, some of these pieces that are up here. So I get rid of some other stuff. These are all relationships. When they say identities, it might as well say relationships. And maybe that's a better word. I like that. You tell me if you remember or recognize this relationship. Do you remember that tangent of theta is equal to sine over cosine? Good. And that's one that we've covered before. Did you know that tangent is the inverse of cotangent? Good. Then you know that. So these are pieces that we will use. Cosecant is the inverse of sine, and sine is the inverse of cosecant. You remember that? Some people say that they get mixed up with cosecant and sine, and then secant and cosine, that they want the cosine and the cosecant to be together. Sam, didn't you say you had a way that you memorized that? Yeah, the C and the S's each go together. So as you can see here, C and S go together, and S and C go together. Okay? So that's one way to remember it. Okay? The other way that sometimes people remember it, they say secant and they say cosine, and you know that's the one that matches up with opposite letters on the other. I don't know how you want to remember it. I don't. You just got to remember it. So anyway, so that's something that's helpful. And then cotangent is cosine over sine. If tangent is sine over cosine, then cotangent must be cosine over sine. Yes. And then cotangent is obviously the inverse of tangent. This is the one I want to bring you though to right now, and you don't have to write this down, but you sure can. Do you remember that sine squared of an angle plus cosine squared of an angle is equal to 1? And then what we did is we divided through by sine squared, and we got this. Then we divided through by cosine squared, we got that. Well, from these three Pythagorean identities involving trigonometry, we get a bunch of other formulas. And I'll just show you one. Well, I'll show you a couple. Watch this, okay? I'm going to subtract sine squared from both sides. And I get cosine squared of x is equal to 1 minus sine squared of x. So, yeah, sine squared plus cosine squared is 1, but you should also know that cosine squared is equal to 1 minus sine squared. And I have that written for you right here. Do you know what else we know? Look at 1 minus sine squared. Do you notice anything interesting about it? It's the difference of two squares. It's factorable. And as a matter of fact, you could write this as cosine squared of x is equal to 1 minus sine of x times 1 plus sine of x. And so, as you can see, there's a lot of different ways that we can express this. So when you see cosine squared and sine squared and a 1, all these are different pieces that we can use and manipulate to make equations work out better, to reduce formulas, to do all sorts of things that are valuable and important. And the same types of relationships exist for secant and cosecant and tangent and cotangent. You can see all the formulas expressed there. So that's a sheet that you will want to refer to a lot. Now, if you flip over to the back side, I just want you to notice definition of 6 trigonometric functions. Does that look familiar? I gave you that on your very first sheet of notes when we did the unit circle basics. So we've seen that before, and you can see that some of those identities are in there. Cosecant is the inverse of sine, so on and so forth. But this Pythagorean identity piece right here, sine squared plus cosine squared is 1. That box is what I have taken and put all on the front here, okay? So that one box I've made all those formulas from for you. All right? So you can be familiar with them. And all we do is a little bit of algebra to get those formulas, as you can see. And I know you know how to subtract 1 and subtract sine and cosine, yada, yada, yada. So let's actually try a problem. Okay? Take out your worksheet. Open up to that piece. Make sure your name is on it. This process is kind of telling for each individual. Some people second hour said that they loved it. They thought it was great. And some people said that they hated it. So it's really up to you. And one method that we use to be able to reduce trigonometric expressions and to simplify them is this. Convert to sine and cosine and simplify. As we do Unit 7, and we work through all sorts of trigonometric relationships and formulas and reduce things, I can't tell you that there's one way to do it. You may want, like last unit was great, right? I could give you 4 steps. Identify the vertical shift, identify the amplitude, identify the period, divide it into 4 spots, then draw your sketch, and then apply the horizontal shift. And it was great. We had a process. We solved it all the way. Not the case now. Now it really rests on your problem-solving abilities and your work as a mathematician. So I'll just show you how one of these works out. These are the most basic problems from the unit that I could come up with. And your book has like 8 problems on it. I've drawn it out to like 40, so we get really good practice with it. So sine times secant. That can be simplified. Sine times secant is something else. And one way that we work to simplify things is rewrite in terms of sine and cosine. Sine is written in terms of sine, so I'm just going to write it, sine of theta. And I'm going to write over 1, and you'll see why in a second. Secant of theta. Secant of theta is not expressed in terms of sine and cosine. How could I write it in terms of sine and cosine? 1 over cosine. And if I multiply those, I get sine of theta over cosine of theta. What is sine of theta over cosine of theta? Tangent of theta. So sine times secant reduces to tangent. What do you think? Not too bad. Let's try another one. Cotangent. That's not written in terms of sine and cosine yet. How could I do that? Cosine of theta over sine of theta times sine of theta over 1. What happens? Sines cancel. You're left with cosine of theta over 1, which is just cosine of theta. How's about secant? 1 over cosine of theta. Cosecant. 1 over sine of theta. Huh. Does anything happen there? Nope. It's already simplified. So sometimes you'll want to simplify something. I mean, as I work through things mathematically, sometimes I come across that stuff. I'm like, well, I wonder if it works out. And we'll try it, and lo and behold, it does or doesn't. We had a great problem a couple months ago in calculus, and we thought that something existed that was a trigonometric identity, and we tried it out, but it didn't work out, and so we worked back. But I think you guys can practice a couple of these. Rewrite them in terms of sine and cosine. See if you can get something to cancel. And after you get an answer, if you want me to check it, that's fine. But why don't you come up here and put some answers on the board for me, okay? So if you get D, come up here and put it up there. And if you get it wrong, that's fine. Nobody will remember to put it up there. So I'm going to press pause. I'm going to come around and help you. And when you get one, come and put it up here on the board. Okay, we're going to pick up with problem J here. It looks like the other ones people have gotten. In case you need to look back, I guess you could pause the YouTube video and look at the results. But these are all correct. J was the problem, and we decided to rewrite tangent as sine of theta over cosine of theta. Now at the bottom we have cosine of theta over 1 times 1 over sine of theta. So So what do you get on the bottom? Cosine over sine, right? And so I can say, well, I'm going to multiply by the reciprocal, which is going to be sine over cosine. Because we get cosine over sine on the bottom, so we can multiply by the reciprocal, and we get sine over cosine on top, right? So on top, you get sine squared over cosine squared. What's sine over cosine? Tangent. So sine squared over cosine squared is tangent squared. And we put the squared by the tangent because we don't want to look like we're squaring theta. We're not squaring theta, all right? How'd those go? They go okay? All right. Flip over to the next side. And you guys don't have any homework today. But we have time to start a couple of these. As you see, 1 minus cosine squared times cosecant, taking all the algebra that you have, there should be this like inner desire to do something right away. What do you want to do? Distribute. You need to rid yourself of that desire because it's not always the best scenario. And we could get it to work out, but it might get kind of ugly. There's a better way to handle this. And if I see 1 minus cosine squared of theta, I know I can actually insert something for that because I remember my formulas. If I look back at my formulas, I know this. Sine squared plus cosine squared is 1. And I can manipulate that to look like this and this. So remember, I have 1 minus cosine squared. So what can I substitute for that? I can substitute sine squared. So as I go to that problem, instead of a 1 minus cosine squared, I have a sine squared. Times cosecant can be rewritten as 1 over sine. And what happens? One of the signs cancel. You're left with sine of theta. Now, let me do O for you as well. And then if you want to, you can try to finish up the other problems. Oh, Ben Jones was making fun of Christine Peterson, which happens all the time. Anything that involves a llama involves Christine Peterson. So just watch YouTube later and pause it, and you'll be fine. So I'm sure Ben would redo it for you if you would like. So for O is a different scenario, though. If you look at O has a tangent squared that has been distributed through. So what I want to do is I want to actually, this time I am going to factor something out. And I can't tell you that you always do one or the other. You got to be able to recognize it. So last hour, second hour, I had a lot of trouble with this. I'm going to rewrite this. Don't write this down. I'm doing this for your benefit right now to watch. I'm going to rewrite that to look like that. X squared minus y squared times, or x squared times y squared. What is the common factor I could take out? And you're left with, right, so we're going to do that same thing, except instead of our x's and our y's, we're going to use tangent squared and sine squared. So what's the common factor? So I take out a tangent squared of theta, and I'm left with 1 minus sine squared of theta. Now that's helpful for me, because I know how to work with 1 minus sine squared of theta. From looking at your formula sheet, what is 1 minus sine squared of theta? Cosine squared of theta. If you look at your sheet, it says 1 minus sine squared is cosine squared. And you guys will get used to that after a while. You'll start to memorize those, trust me. We'll do enough of these. And so now that we have that, let's see here. Okay, so I have tangent squared times cosine squared then. How do I rewrite tangent squared? Sine squared of theta over cosine squared of theta times cosine squared of theta over 1. What happens? Those cancel. I'm left with sine squared of theta. So we'll pick up with here on Monday, but if you'd like to try a few of those problems, go ahead.